Dear students, greetings. Welcome to the course Advanced Machining Processes. Course code is BTME3056. In this Advanced Machining Process course, we'll be studying various advanced machining processes like ultrasonic machining, advanced abrasive jet machining, water jet machining, electrochemical machining, electric discharge machining, and in beam machining, laser beam, electron beam, ion beam machining, and also some of the advanced finishing processes like abrasive flow machining and magnetic abrasive finishing. In all these processes, we'll be studying the mechanism of material removal, or how the material removal takes place, and the process or the equipments, and the application of these processes, advantages and disadvantages of these processes, the need of these processes. So this is a very interesting course which covers most of the advanced machining processes technique. It's completely different from the machining processes which we have studied. Like it's completely different from traditional machining processes. We know that manufacturing processes can be classified into primary shaping processes as well as secondary shaping processes. Primary shaping processes are the one which gives basic shape and size to the material as per the design requirement. Casting, forming, powder metallurgy, these are the examples of primary shaping processes. Whereas machining process is an example for secondary shaping processes, which gives the final shape of a material with a dimensional accuracy and a specific surface characteristics as per the design requirement. Generally, conventional machining, we use a cutting tool which is harder than the workpiece material. When the cutting tool is pressed against, or a force is given against the workpiece, the cutting tool with the cutting edge removes the material from the workpiece material, and we get the final or desired shape and size of the workpiece material. So machining processes produce materials with high degree of accuracy and surface quality. But even in conventional machining, we face challenges, like there are some materials which are hard to cut, like materials of high hardness and materials of high brittleness. And when we require higher productivity than the normal conventional machining that can offer, and when we also have the requirement of very high product accuracy, or dimensional tolerances, and very high surface quality, then we'll have to choose a method other than the conventional machining methods. So here comes the need and the use of advanced machining processes. As we can see from this diagram, the machining accuracy of a machined product is plotted against the number of years of advancement. Initially, we just look at in case of turning and milling machines, grinding machines, where the diagram of workpiece is given to a man who is operating the lathe machine, and he sets up all the machine and equipments, and he operates the machine in such a way that, see, he's able to produce initially with the dimensional accuracy of maybe 10 raised to the power of -3 inches, or in case of 100 nanometers, or 1/10 of a micrometer. But when it comes to the advancement of CNC machining centers, still we are able to produce a machining accuracy of 1 micrometer, even beyond 80s. After 80s, with the invention of lapping and honing, jig boring and grinding machines, some of the advanced precision machining techniques like optical lens grinding machining, precision grinding, super finishing, diamond grinding and turning machines, we're able to still manufacture the materials with the machining accuracy of 0.1 micrometer, that is 0.1 into 10 raised to the power of 6 meters, -6 meters. So with increased advanced technology of having computer numerical controlled turning machines, milling machines, or the lathe machines, in the later 80s, we still increased the machining accuracy around say till 0.01 micron meter. With the advanced techniques of advanced machining process like electron beam machining, soft X-ray lithography, hand beam machine, molecular beam epitaxy, or other advanced techniques like an implantation, still we're able to machine beyond micro machining with the accuracy of 1 nanometer. So the thing is, with increasing challenges in its material requirement, with dimensional accuracy, with increased advanced level of science and technology, we are able to have high machining accuracy products with advanced machining process. As we saw in the previous slides, um, the challenges of the material properties that lie like harder and stronger, tougher materials that are more difficult to cut. Not only that, the challenges that are with the design aspects like very difficult complex shapes and surface integrity and the size requirements. Even we are able to machine, we need to have machining characteristics of a very tight tolerances. So in both the aspects of material requirements like ceramics, composites, which are really harder and brittle, and some of the advanced materials, as well as the design complexity, makes to look for another possible alternative machinability methods. Especially these materials of advanced materials and very tight tolerance materials are needed in aircraft, automobile, tool, die industries. So we need to look for a method other than the conventional machining methods which can meet these challenges. The advanced machining processes help us to meet these challenges. After having known about the need of advanced machining process over the conventional machining process, now we'll look at the differences between, or we compare between the conventional and non-conventional manufacturing processes. In case of a conventional machining processes, chip formation by shear deformation is inevitable. But whereas in case of non-conventional manufacturing process or advanced machining process, chip may or may not form. For example, in advanced jet machining, chips are of microscopic size. Whereas in case of electrochemical machining, we remove material because of dissolution at atomic level. So the chip may or may not form in advanced machining process. In case of conventional machining, definitely a physical tool which is present. In case of non-conventional machining, may or may not present. For example, a laser jet machining, machining is carried out by a laser beam. Whereas in case of electrochemical machining, there exists a physical tool. So in case of non-conventional machining, physical tool may or may not present. But in case of conventional machining, the work tool, tool is present, which is harder than the workpiece. Then only it can, when it is when force is given to tool, then it removes the material. And not only that, the tool is harder at any temperature and any machining condition. But in case of non-conventional machining, tool and tool may not be present, and we cannot say that even if a tool is present, the tool is harder than the workpiece. In case of conventional machining process, the cutting forces are mechanical alone. We just apply cutting forces So we can call the energy domain is mechanical, whereas in case of non-conventional machining, different forms of energy, thermal energy, electrical energy, chemical energy, and all these energies are applied to remove the material. So chip formation, physical tool, harder work tool, cutting forces, these all are the essential differences. We will also look some of the other differences of conventional machining over I mean, in case of a conventional machining process, there exists a direct contact between tool and workpiece all the time. But whereas in case of advanced machining process, it is not necessary that the tool and workpiece should be in contact with each other. In case of a conventional machining process, the accuracy and surface finish is lower. But whereas in case of advanced machining processes, the machining dimensions can be possible with high accuracy and high surface finish. The conventional machining is suitable for every type of material economically if it is possible to be machined. Whereas in case of advanced machining process, it's not suitable for every type of material economically. We have to choose which material is suitable for which type of process. But in case of a conventional machining process, tool life is very less because of very high surface contact between tool and workpiece, and there is a lot of wear between the workpiece and the tool. But in case of advanced machining process, the tool life is always more. Though the tool is quite costly to make, the tool life is more in case of advanced machining process. Since because of the very less accuracy, the wastage of materials in advanced machining processes is very less. But whereas in case of conventional machining process, the wastage of material is very high because of very less accuracy. The other differences can be like the conventional machining processes, the operation could be quite noisier, and but most of the advanced machining processes are quieter in operation. There is no sound pollution is produced because of advanced machining processes, because you can completely seal the environment. Cost wise, the conventional machining processes are cheaper, only at initial cost or lower capital cost. But when it comes to the advanced machining process, the setup of cost or the machine cost is quite higher. The comparing with the setting up of difficulty, the conventional machining process can be set up easily, but the advanced machining process require complex setup level. Skilled or semi-skilled labor can be utilized in conventional machining processes, but definitely we require a skilled operator for advanced machining process because of the lot of process that is required in operation. Most of the conventional machining operations are manual or automated, but generally the advanced machining processes are automated, fully automated processes. So if we just look at it, for creating any prototypes, the conventional machining processes cannot be used to produce very efficient and economical prototypes, but whereas advanced machining processes can be used to produce prototype parts very efficiently and economically. Now let's look into some of the traditional machining processes, which will help us to classify later in non-traditional machining processes. So the material is removed by the cutting action as well as the abrasion action of abrasives. In case of if we want to cut the material by circular shapes, we use turning, boring, drilling methods. For other shapes, we use milling, planing, shaping, broaching, shawing, filing, gear forming, gear generating methods in machining process. In case of a mechanical abrasion methods, we use bonded abrasives as well as loose abrasives. We use bonded abrasives in grinding, honing, coated abrasives. In case of loose abrasives, we use it to use polish and in buffing. So this on the basis of sources of energy, the non-traditional or advanced machining processes can be classified into mechanical source and thermal source and chemical and electrochemical source. In case of a mechanical source, a mechanical action or mechanical force is applied on a material to remove the material. For example, ultrasound machining, water jet machining, abrasive water jet machining. These are the methods that they use mechanical action to use to remove the material. In case of a thermal energy, the thermal energy is applied to melt or vaporize the workpiece and then remove the material. Most of the beams like electron beams, laser beams, ion beam and plasma beam machining, they remove the material through thermal sources of energy. And we also remove the material by chemical and electrochemical action of materials, chemical machining and electrochemical machining. These use chemical and electrochemical sources of energy to remove the material. So conclusively, like we can say, the major sources of energy that are applied to remove the material in advanced machining processes are three: mechanical, thermal, and chemical and electrochemical sources of energy. On the basis of this, the advanced machining processes are classified. The advanced machining processes can never replace any conventional machining processes. And at the same time, not all the type of machining processes are suitable for all the materials and all the conditions. So these processes have to be selected on the basis of materials, on the basis of physical or facilities available, on the basis of the type of geometry or the process capability that is available, and the requirement of all the work material and the shape that is to be machined. So on the basis only the processes, the selection of the advanced machining processes have to be chosen. Coming to physical properties, these are the physical properties that on the basis of which the process has to be defined. Potential, which voltage and what is the current that is available, what is the power that is required, and what is the gap that is to be given between the tool and the workpiece, and what is the working medium like abrasive slurry or abrasive in gas or electrolyte, or there are some chemicals that are used as a medium, and there is air that is used as a medium, argon and nitrogen that is used as medium. So there are various physical properties on the basis of which the process has to be chosen. Coming to the shape, what is the type of holes, or what is the precision that is required, what is the aspect ratio that is required, what is the minimum dia or maximum dia of each processes, these vary. Not only standard length of a hole, like what is the minimum length and maximum length of all these processes that has to be done, what is the cavity, through cavities of precision or standard cavities that has to be done. Some of the processes like through cutting, shallow cutting or deep cutting that are required. So shape requirements, and these processes have certain limitations. So the processes have to be chosen on the basis of this requirements of process capability. Not only that, few materials also, selection of suitable materials also require some of these process selection. For example, aluminum and superalloys cannot be machined with ultrasonic machining, whereas electron beam machining can be used to machine any type of material, whereas plasma arc machining, refractories and plastics cannot be machined because of the high heat it may melt. So there are lots of criterion that is available on the basis of which the suitable advanced machining processes are. The other processes capabilities that are available here is what is the material removal rate, that is millimeter cube of material per minute. and what is a tolerance limit in microns, and what is the surface finish of the material after the machining process has been done, and what is the surface damage that is done to the material at the end of the process, or what is the surface damage depth, and what is the corner radii that is available and that is in the process within in millimeters, or how much of tool that is varying per material volume of material that is removed, or what is the tool wear ratio, is the process safe that is used for all of the places, or is there any toxicity that is associated with this processes. So when selecting this process, all these parameters have to be considered and chosen carefully for applying before applying any process. Apart from the NPTEL sources that are available in the internet and so many videos that describe and show the processes visually, we'll be using two textbooks for this course. One is Advanced Machining Processes by V.K. Jain, published by Affiliated Allied Publishers. We'll also be using an ebook, Advanced Machining Process by Hassan L. Hofi. These books give a basic overview of these processes, and yet some of the assignments which we will be working with, you may have to take the need of internet or the online resources to cover the entire course. Thank you for patient hearing.